Alright, looking at number 1, substitution. This was already set up for substitution. Y is equal to 2x. So instead of y, I'm going to put that 2x in there. And then I just solve the equation for x like normal. I'm going to get a 5x is equal to 35. I'm going to get an x is equal to 7. Once you get this x equal to 7, you can take it and you can put it back into your original equation. I'm going to get y is equal to 2 times 7. So y will be 14. That'll be my answer there. On this one, neither equation is set up solved for a variable, but one of them is significantly easier. This one, if I add y to the other side, or if you subtract 3x and divide by negative 1, either way, I'm going to solve for y. Y is equal to 3x. Now this time when we put it in for y, you'll notice this 2 out in front. We have 2 y's. Y is equal to 3x. So if we had 2 y's, we're going to have 6x. What I'm going to do is I'm going to show you that math in the problem right here. So I have 2 y's, 2 times 3x, 6x. And we're going to get a very particular little answer here. 6x minus 6x is 0. You're going to get 0 with 5. This is going to end up being a no solution. And the reason this is a no solution, if you solve both these for y, so y is equal to 3x. And then this one, if you solve for y, y is equal to 3x minus 5 over 2. You'll notice that they're parallel lines. And that's a way you could check this out. If you get on the test and get something like this, solve for y. They may be parallel, and if they're not parallel, you did something foolish. Not good. But if they end up being parallel, you know that this is the case, and it's a no solution graph. They're not going to cross. Number 16. Again, picking the right equation, the right variable to solve for. I'm going to solve for x in the second equation. If I solve for either variable in the first, I'm going to get a whole bunch of fractions. We don't want that, so we're not going to do that. I've solved for x, so now I have 3 x's, and I know x to be 3 minus y, plus 2y is equal to 9. At this point, I can just distribute that 3. Take the 9 to the other side. Turn that page. I'm going to get negative y is equal to 0. So y is equal to 0. Notice the difference. This is 0 in a number. This is y equals 0. So this is an actual value we're going to use. And then I have x plus y is equal to 3. So x is equal to 3. Or you could do 3 minus 0. You're going to get the same answer. This one, I'm going to use this equation right here, number 17. Add that 3x to both sides. Y is equal to 8 plus 3x. And I'm going to take this, substitute it in for y. So x plus 2y is equal to negative 5. So x plus 16 plus 6x is equal to negative 5. Take that 16 from both sides. I'm going to get 7x is equal to negative 21. So x is going to be equal to negative 3. Once I put that in, negative 3, I'm going to use this equation. Negative 3 plus 2y is equal to negative 5. Add the 3 to both sides. 2y is equal to negative 2. Y is going to be equal to negative 1. Alright, elimination. Adding those two together, hoping something cancels out. If something doesn't cancel out, we're going to adjust. So, this first one, the y's will cancel out. Y minus y, 0. 7x, 5x, 12x. 22, 14, 36. So x is equal to 3. So I've got 7x plus y is equal to 22. I'm going to subtract the 21 from both sides. Y is equal to 1, and I'm finished. Much faster, requires a little bit more brain power, but much faster. Number 19, notice nothing's going to cancel out when I add it together. So I'm going to take this top equation, multiply everything by negative 1, and now when I add it together, things will cancel out. Negative x plus x is 0. 4y minus 2y is 2y. Negative 6 plus 18 is 12, so y is going to be equal to 6. I'm going to take this equation, x minus 2 times 6 is equal to 18. Add the 12 to both sides. X is equal to 30. I'm all done here. Now, this one. Take this top equation. I'm going to multiply it by negative 3. That's going to give me negative 15x. Oh, positive 3. My bad. Positive 15x plus 9y equals 51. At this point, I'm going to get 17 x's. My y's will cancel, and I'm going to get 68. Divide both sides by 17, and x will be equal to 4. I'm going to take this equation right here, Put that 4 in for x, and solve for y. Pull the 20 from both sides. 3y is equal to -3. Y is equal to -1. Last one. I'm going to multiply this bottom equation by -2 because I don't like fractions, and I know my y's will cancel out if I multiply by -2. But something, again, interesting happens. X minus x, 0. 2y minus 2y, 0. 6 minus 6, 0. You'll notice everything cancels out. Doesn't matter what you put in for your variables, everything will cancel out. This is going to be an IMS. And if you ever run into this situation, solve for x, or solve for y rather. If we solve for y here, y equals -1/2 x plus 3. If we solve for y here, y equals -1/2 x plus 3. You'll notice it's the same line. So, just like in the front, it'll cross at every single point, and IMS will be your answer in that case.